welcome back. Today we're going to talk about the equivalent force systems. This is part of statics and is required on the FE civil exam. What is an equivalent force system? Let's take this example here. When you have a system with forces like this one, in order to create an equivalent force system, you have to reduce all of these forces to one resultant force and to one moment about a point required in the problem, such that the resultant force in system number one is equal to the resultant force in system number two. And the same with the moment in system number one about certain point asked in the problem is equal to the moment about the same point in system number two. We're going to understand this better once we work on an example. Replace the force system shown below with a force coupled system at the support A, and B, a force-only system on line AB measured from point A. So we have two things to do today. First, this is going to be option A. We have to come up with an equivalent system that has a force and a moment about point A, where the resultant moment and resultant force in this system number two, I'll call it, is equal to the resultant force and moment about point A in system number one. So in order for these two systems, let me call this one, and this is two. In order for these two systems to be equivalent, we're going to say that R1 has to be equal to R2, and M1 about point A, specifically in this problem, has to be equal to M2 about point A. Only then these two systems are equivalent. And then B, option B, we have to come up with a force-only system on line AB measured from point A. So we have to come up with one single force. Let me say, I'll place it here, such that, so we're going to have to find this distance as well, such that the resultant force in system number three equals to the resultant force in system number one, and moment about point A in system number three equals to the moment about point A in system number one. Maybe it seems a little bit complicated, but I'm assuring you it's not. So let's go ahead and start with A. Replace the force system shown below with a force coupled system at the support A. So first, what we're going to do, what you're always going to do, sum of forces in the x direction. And make sure you do not set this to 0, because sum of forces is not 0 unless you have a force going this way, another force of 100 going that way. This is going to make it 0. But sum of forces by themselves, it's not 0. Sum of forces on the x or y direction are 0 when we consider the reactions. That's when this system is in equilibrium. But we're not working with reactions, so do not make it 0. So let's see. We're going to have 24 kips. And then we have this 30 kips force with a 50-degree angle, makes a 50-degree angle with the horizontal. I'm going to make a stop here, and even though on the exam I want you to skip this part, I want you to be able quickly to read on this beam what is the x and y component. But until you get to that point, I'm going to build this. So this is 30. This makes a 50-degree angle with the horizontal. So this is my horizontal force, like this. Let's call it Fx. And this is my vertical force. Let's call it Fy. And we know we have to build a, if I was to translate the Fy here, this makes a 90-degree angle here with the horizontal. So this is a right triangle. And we apply sine and cosine in the right triangle. So this is Fy. So if we apply sine of 50 equals to opposite, which is Fy, over hypotenusa, which is 30. So from here, Fy equals to 30 sine 50. Same thing with cosine. If we apply cosine in that right triangle, we're going to get the adjacent, which is Fx, over hypotenusa 30. And from here, Fx equals to 30 cosine of 50. So what I want you to practice this so much that on the exam, you are able to read these results right away, skipping this whole thing here. So now moving forward, I'm going to say plus. We have the horizontal force because it's adjacent to the angle, right? This Fx here. Because it's adjacent, I know right away this is cosine. So I'm going to say 30 kips multiplied by cosine of 50 degrees. I don't have any other horizontal forces. So this is going to be equal to 50 cosine 30 multiplied 24 plus. This gives me 43.28. So sum of forces in the x direction equals to 43.28 kips. Great. Step number 2, you're going to do sum of forces in the y direction equals. I'm going to go here to this force. The y component of this force is going to be opposite. So I'm going to have Fy. Fy is 30 kips multiplied by sine of 50 degrees. And it's going downward, so I'm going to say negative. And next I have this distributed load also going downward, so it's going to be negative 3 kip per foot multiplied by 6 feet. Feet goes away. So I'm going to get, let's see, 50 sine 30 multiplied 18 plus. Sum of forces in the y direction, I get minus 40.98 kips. Or I can say 40.98 kips going downwards. And for the x forces, going to the right. And number 3, what you're going to do, we're going to do sum of moment about point A, because we are asked to come up with the couple moment about point A equals. Now, you know, when we have that sign conventions, the moment about on the left side is positive when is clockwise, and on the left side, or the other way around, on the left side is positive when it's clockwise, and on the right side, it's positive when it's counterclockwise. In our case, we're going to have a positive moment clockwise. So point A, we have, starting with this moment, minus 50 kip foot. Okay, and then this 24 kips force, it's gonna rotate counterclockwise as well. So I'm going to continue with 24 kips multiplied by the arm, which is 4 feet. Okay, so I'm done with this one, done with this one. And then I have this force, 30 kips force under a 50-degree angle. I'm going to take the Fx, which is going to rotate this clockwise. So now I have plus, and I have the x component, which is 30 kips multiplied by cosine of 50, and the arm is 5 feet. And then I have plus. I'm going to add the y component, and the y component is 30 kips multiplied by sine of 50 degrees, and the arm is 12 feet here. 12 feet. And next, I will have this distributed load rotating clockwise. So I'm going to have plus 3 kip over foot multiplied by 6 feet. So now I have the resultant force for this distributed load. And I have to also multiply it by the arm, which is 15 plus 3. I get 18 feet. And I have no more forces equals. So let's see, let's calculate this. And please calculate with me. Take the time, stop this video, and calculate with me. Make sure that I have done my calculations correct. I'll start here with 50 negative. And then I have 24 times 4, get 24 multiplied. Okay, 146 negative. Next, I have 50 cosine 30 multiplied, 5 multiplied, and that's plus. Next, I have 50 sine 30 multiplied, 12 multiplied, plus. Next, I have 18, 3 times 6, 18 multiplied, plus. So I get a moment of 550, approximately 0.2. And this is kip foot. Perfect. So now if I would like to draw this system or this frame, let's say, this is support at point A, and this is the support point B. I have come up with a force, the horizontal force of 43.28, and I have calculated a vertical force of 40.98. And also I have a moment, clockwise moment, of 550.2 . Okay. So the problem is asking me to come up with the resultant force, which is obviously easy to do. You can just say the resultant force is going to be equal to square root of 40.98 squared plus 43.28 squared. Please use your calculators with me. So I'll have 40.98 squared, 43.28 squared plus square root of that. I get that the resultant force is equal to 59.6 kips. So there you go. We just have come up with a system equivalent to the initial system. So these two are equivalent because the resultant force in system number one, if you were to calculate the resultant force in system number one, is going to be equal to this resultant force. And if you were to calculate the moment in system one, it's going to be equal to the moment in system two. This is why these two are equivalent. So looking at the answers here, it seems so we have a resultant of approximately 60, right? And the moment is 550 kips put. So the correct answer is D. Now, moving forward, let's go to B, where we have to come up with an equivalent system with a force only on line AB measured from point A. So when you are given this, you have to follow the same steps we did before. You have to do one, sum of forces in the X direction. You have to do two, sum of forces in the Y direction. And three, you have to do sum of moment about the point, in our case, about point A. But we already have done that. We have done all that, so I will not repeat it. I will just go ahead and draw here the resultant force and the moment that I have calculated in my problem before. And I know that the resultant force that I got, it's approximately 60 kips, and the moment is 550 approximately. So I'm going to use these two values. And now how do we come up with a force-only system on line AB? Well, let's think about it. The moment is equal to a force multiplied by D. So I have to take this resultant force and move it somewhere on line AB, right? Let's say if I was to move it here, such that when I calculate the moment about point A, I get the same moment as in system number one. So what's going to happen? The moment, it's 550 equals to, we're going to have D, we have to calculate where on this line AB, we have to calculate the force. And now what's the force? What's the force? When calculating a moment, we know that we have to multiply the force with the arm, and we know that the arm has to be perpendicular to the force. So please do not make that mistake of putting 60 here, because it's going to be completely wrong. Because this force, 60, it's not perpendicular to this distance here. This is D. Let me delete that. So what we're going to have to do, we're going to have to bring back our horizontal and vertical force. In this case, we notice the horizontal force goes straight to this point A, so it doesn't create any moment. So all the work is done by this Fy. And let's see, what is Fy equal to? Fy, right, is equal to 4098. So we have Fy equals to 4098 kips. So over here, I'm going to have 4098 kips. And from here, we're going to do D equals to 550 divided by 40.98. So 550 divided by 40.98. And I'm getting a value of 13.4. 13.4, and these are feet. What this means is that if I move this force of 60, 13.4 feet away from point A on line AB and place this force here, I have just created an equivalent force system with this system 1, and of course with system 2 because they're all equivalent. And this is because sum of forces in the x direction in both systems, you're going to find that they're equal. Sum of forces in the y direction in both systems, you're going to find, so this is 3, system 3, you're going to find that they're equal. You're going to find that the sum of moment by the point A in system number 1 is equal to the sum of moment by the point A in system number 3. Looking at the answers, my friend, it seems that I get 13 point. D is the correct answer. I hope you found this helpful. If you have any questions or if you didn't understand something, please leave your comments in the comment section below. Otherwise, my friend, I will see you next week.